Since there are many changes has been done in design of earth dam, so I am going to give demonstration for the earth dam design and detailing. For that I take example as the Kovilmalayar project. Now I am going to run this by running this shortcut. I create as new project because old files may not work correctly. So I will create as new project. The project name is Kovilmalayar Earthdam. Equal project files. This is burned in, it is coming in the category of burned tank wear solution. So in this I select it as Earthdam. Okay. So these things are not necessary for the Earthdam. I click OK. Now the project is created. You will see the project file is created. In the status of the status window, you will see this. Now you are going to give input data. This only Earthdam input data is necessary. So for that you are giving Earthdam input data. Click on this. Earthdam input not yet given. Earthdam input to add. Okay. So for that easy purpose, I will give old Kovilmalayar project. In this there will be some old data. Stability input. Okay, I will open this file. In this, the height of the dam is here. I will copy this. And in this, I will copy it as paste, or you can type it also. Top width of the dam is 5 meter. Then top bund level, copy, paste. Then max flow water level. Paste. Full reservoir also same. Draw down level. This is minimum drawdown level. Yes, based on this, top width of IP set is 3 meters. Then bottom cut width is 4 meters. You can see this also. Top width of IP set 3 meter. Bottom cut width 4 meter. Horizontal acceleration coefficient 0.12. Depth of IPZ from TBL 1 meter. Size of IPZ slope 1 horizontal is to 1 vertical. So these are all the values. We have fed it already. Okay. Next, we will feed the soil properties data. For that, we have to close this. And from this, open soil properties. This from this CSV file, we can give this is SPZ properties. Edit, copy. Yes, this is SPZ bulk density, then saturated density. This is SPZ saturated density. Then this is cohesion of soil. And this is 25 degrees. And for IP set, this is saturated density. Then cohesion is 3, angle of interpolation 25. For this same SP set values is used here. If you know exact values, you can give that exact values also. So these are all the values we have done with the soil properties data. Then what are all the slope data available? You can find it from there, or you can give your own data also. For this, I used one thing, that is for upstream side, I have two number of slopes. So one is 2.5 is to horizontal is to 1 for 8 meter and 3 horizontal is to 1. The height of balance 3 or 6.19 meter. How I am going to give this? I am going to see serial number 1 is the first slope. Here it is 2.5 is to 1. Height is first 8 meters. Click next. Balance at 6.15 is there. This is for second slope. For that I will give it as 3 is to 1, 3 horizontal is to 1. Then here 6.195. Okay. Click next. So the balance side becomes 0. So similarly you can give for downstream. Number of downstream slope 3 numbers, 2.5 horizontal is to 1 for height of 6 meter, berm width is 3 meter. The second slope 3 is to 1. This is also height 6 meter and berm width 3 meter. Third slope 3 horizontal is to vertical 1. Balance height is 2.15. Berm width is 0 because this is the last slope and this is not exceeding 6 meters. So it will join with natural. So I will view it like this. Serial number 1. This is first slope. Here I will give 2.5 is to 1. This is height between berms 6 meters. 3. Click. For the second, I will give it as 3 is to 1 slope, 6 meter, 3 meter, then click next. For third slope, 3 is to 1 balance height between berms, I will give it as 2.195. Here, berm width you should not give it as 0. Okay, because it is within 6 meters, it is butting with the natural ground level. So, with 2.195 meter is the height between berms. Berm width is 0 because it is reaching the ground level. Okay, next. So balance side becomes 0. So here also balance side becomes 0. You click OK. Input file is loaded. If you open this input file now, don't change it. Just click on input file already given. So here you will see the balance side is 0. So don't change it. You have to give this type of data. Then only it is correct. In old screens, these things are not added top with the IP. These are all default values taken. So that is why that file, that input data won't work now. So you have to feed new data like this. Okay. Oh, that's all. Now we can draw the generator. Okay. This is the template drawing. Okay. We open with AutoCAD application. Now this is drawn. Now click on ISHI, go to Earthdam, load Earthdam. You see soap safety analyst program loaded. Then you click on Earthdam, slope analysis. You click on this because we have not saved here. Save as. This is the first command we have to do. If you have not done this type of errors will come. Now you go on Earthdam, you just learn slope analysis. That's all. It has been drawn. Both upstream and downstream analysis are drawn. If you want to see the upstream values, you can make this layer of upstream layer on and keep it as the current layer. We want to see the stability of this. See project files, Kovilmalayar Earthdam. When this upstream 0.csv is there, you do this like this here, modified, open. Here also with these values. You can have a print screen command here and copy this area and edit paste. This is the default values, default failure circle drawn by the software. Similarly, we will do the downward side also. We make this layer of downstream layer on, keep that as current layer, see the same program, that is downstream 0.csv, open it. Here are the, if you do the print screen, rectangle, edit, paste. You can paste it here. This is the downstream. This is without earthquake safety, with earthquake safety. These are all the lines. I just copied from that. Now you can off this layer also. Now we are going to take trials. So for upstream curve, first we will take the curves. The default point is taken up here. Now we will take the point somewhere here. Okay. So for that, you are off this layer. Make the 0 layers as current layer. Set it. Then draw a circle. We'll keep this point here as the center, and we will draw a circle. Okay, now trim it. This is the cutting edge. Now this is the failure curve. You are going to check the stability. So give command as trials, or you can in this menu also it will be available. I think Earthdam trials. Okay, trials. This is the first trial. 0 trial is the default trial. First trial. This is for upstream. You then select the failure curve. This has been drawn. Now you go and check for, you have done upstream 1. Okay, open 1.632. Just have a rectangle. This area you copy, edit, paste. This is for this curve. This is drawn in the trial U1, upstream 1. This is the first point. Center point, you remember, first center point is there. So we will create some other place. There is almost center of this. We will do the trial. Keep this 0 layer set and on. Then circle command. We give it as same center. Okay. Now trim. Run the trials. Trials. This is the second trial. This is upstream trial. Select the failure curve. We have done this. Upstream 2. Here you see the factor of safeties are available there. You can copy this. Edit, paste. This is for trial 2. Okay, I will off this layer. We will take some other point now. This is the second trial. Okay. In the first trial we have taken that point. In default trial it has taken that point. So we will separate, choose another point now. Circle. I will take this point. Okay. Now trim. Run trials. This is third trial. This is for upstream. Select the failure curve. For this, you can see what is the values. Rectangle. Edit, paste. Okay, this is for trial 3. We will took some other center point now. Circle, center point I will take here like this. Now trim or run the trial. This is 1/4 trial upstream. Select the failure curve. This is drawn. You want to check the values. 1.629, 1.165. You can print screen, rectangle. This area I will choose. Then paste it here. Edit, paste. For this curve, it is in this layer. Okay. Next, what point we have taken? We have taken like this. Next point, we take something here, some other place. Keep the zero layer, draw the circle. We keep the point here. Of this type of also. Run the trials. This is 5th trial. Upstream. Select the failure curve. Just draw. This is the 5th trial. Open it. So what is the values? We draw the print screen. This is copy. Ready, paste. Okay. Trial 5 is over. Trial 6 will take some other point. So it will be drawn in this layer only. So we will change it to 0 layer here, preference. So in this layer it is drawn. Okay. Now change. Select object this. Properties layer 0. Then now this of layer of this layer is in 0 layer. I will trim this. Now run the trials. This is the 6th trial. This is upstream. Select the curve. So this is done. You see the factor of safety values now. It is 1.674 rectangle. Copy this. This is the 6th trial. So we have done almost 6 trials, 6 plus 1, 7 trials for upstream. For downstream, default trial is there. So now we will keep something point like this nearby and then do the same. The default values are also pattern here. Here circle, I will choose within the circle center point. Then trim. Now run the trial. This is the first trial. This is the downstream trial. Select the failure curve. Okay. Now you go and see the downstream ones. You can see the values here. So you can print screen the values. You can edit and paste it here so that you can understand for this center point what are all the factor of safety values. Similarly, we will do the second trial. For that, we draw the circle from this as the center point. This will be also drawn in this. We will change this things to 0 layer. Then we can off. Now we will trim this. This is the trim. This is the trim object. Okay. Now run the trials. This trial number is 2. This is downstream. Select the failure curve. These values are wrong. See the values. And have your print screen values where it's so that you can refer from the drawing. Very waste. Okay. This is the trial. Similarly, we will do some trial 3. Circle. We will assume the same as the center. And then I will draw the curve. Okay. Now trim. Trials. This trial is downstream D1, D2 run. This third trial. This is downstream. Select the failure curve. So for this, you will see the values here. In this CSV file, you can print screen values here. So these are all the values for this center and this circle. Okay, we log this layer, then set it to 0. Then we will choose some other points. Lastly, we have tried the point, the same as center. We will select from downwards. Let's see, we have done anything like that. No. And no. Trial 3 is there. Trial 2 we have already taken. So this center is not necessary. So we will do circle with this point as center. Now trim. Now run the trials. This trial number is 4. This is downstream. Select the failure curve. It has been done. This is downstream trial 4. If you want to see the values here, just do the print screen value. Okay, these are all the transformative values. We have taken point here. We have not taken anything there. See, here this one we have taken. Center is taken, inside is taken. Outer point will take this. Circle. Take this as the center point. Draw a circle. Now trim. Now run the trials. This trial number is 5. This is downstream. Select the failure curve. This is drawn. You see the effect of the values from here. Print screen. And paste it. So this is the 5th trial. 6th trial we will take from some other point. Set it. Circle. I will choose this point. Trim. And run the trials. This is sixth trial downstream. Select the failure curve. This is done. We click on the sixth value. Rectangle. So here we have not found any unsafety. So the section is safe. So we have done 6 trials and everything is safe. Now we are in a position to draw the cross sections. So for that we will do the earth dam set command. First 14.19 meter, that is 14.195 meter, you give the full depth of the height of the dam. Then scale of printing 200 you give. This is drawn, that's all. Then you will give the command drop to glass per insertion point. This you can round it here at this area. This area zoom in view is printed here. So 14.2 it is there. Now you are going to draw the earth dam section. This is 8.5 meter height. Scale of 200 degree. This is also drawn. Now give raw code command and press this. This is the for this section. This is the raw code drawing. Next, earth dam section. Now we give it a 7.5. Scale of 200. Drawn. Now raw code command will give. This is the filter alignment for this. Take this layer off. Now earth dam section. We are going to draw 6.5 meter height. Scale of 200. This is drawn. For that we can also give raw code command. This will give filter alignments. Zoom in view. Next, earth dam section. Now you are going to draw 5.5 meter height. Scale of 200. So 5.5 meters drawn. Then you can give it as earth dam raw code. This will give the filter alignment for this. 5.5, keep it soft. Next, you are going to draw earth dam section, therefore 4.5 meter height, scale of 200. This is also drawn. No raw code is filter alignments there, so raw code command is not necessary. Next, we will going to draw for 2.5 meter dam section. Height is 2.5 meter, scale of 20 meters 100. Okay, this is also drawn. See, save this. So now design of earth dam and detailing of earth dam is done. Okay, now save this drawing. Okay, that's all.